we want to give you some feedback on your homework for today, because this was a very good opportunity for us to get a sense of how well you're picking this up. This is kind of like the doctor asking you questions when you go to see them about how you're getting on. They'll ask questions, help them to reach a diagnosis. And that's what this task's about as well. And our diagnosis is good. But there are one or two things that we need to clarify for you, and that's what I'm going to do here and now. This will help you as you get ready to do that GIS task for Miss White, and push you maybe more along the right lines with this. So, I'm going to start off with talking about those threshold concepts that I introduced in my video on Tuesday, whenever I was talking about coastal management at Cromer and Haysborough. And the first of them was this notion of sustainable development or sustainable management. This is something you meet a lot in geography, and you know that it's the coverage of these three things: economic, social, environmental. Whenever you get this overlap between these three, that's what's important. But the other element of this, which is really important, is that this has got to be sustainable into the future. This isn't just about reaching this now. This is about looking ahead, years, decades even, and not tying future generations into the need to maintain this in the longer term. Now think of the live stream that I did from Portrush. Remember the seawall where I showed you where it was broken and where it had to be fixed, and even though it was fixed, it was breaking again. When was that seawall built? Do you remember when Miss White did the Google Earth tour with you? Like, that's built from about the 1930s to about the 1960s. So we're talking about something that is 50 or 60 years old, at least, that's still requiring people today to have to spend money to fix it. Sustainable? I don't think so. So you've got to be thinking about this in the longer term as you move in. Now, when it comes to sustainability, obviously we know that soft engineering is more sustainable than hard engineering. I say hard engineering, you say tries to control, yeah. I say soft engineering, you say works with. Hard engineering tries to control, soft engineering works with. Now, because it works with natural processes, it's going to be more sustainable into the future. Do you get it? Because you're not massively interfering with natural processes now. Therefore, you don't need to massively interfere with natural processes into the future. There you go. That's it. So let's have a look at three methods here. Seawall, where are you going to put it? Hard or soft? Which one? Oh, yeah, of course, it's over here, isn't it? It's trying to control, and that seawall is going to get constantly battered by the waves. It's going to get broken, and over time it's going to need to be repaired. In the longer term, it's not very sustainable, right? Let's have a look at this one. This is managed retreat. This is a very recent massive landslide that occurred along the Dorset coast. Look at that, isn't that class? Actually really scary if you've been down there. But this is a really important picture, I think, because it shows us back to that systems approach. Input, output, stores, transfers. Input, output, stores, transfers. Which of the four is this? Oh, well, this is an input into the system. One of the places that a beach will get a sediment from is erosion from the cliff. And there you go. Massive input of sediment, and that will then be transported along by longshore drift, and it will be distributed around about the beach. Now, if your approach is managed retreat, you're going to allow erosion to take place. That is surely working with natural process, yeah. And that is something that's not tying the future generations into costly management. Okay, this beach nourishment. Hard or soft? Hard or soft? Well, it's working with the natural processes in that it is using the natural beach to protect the coastline. But look, there's a degree to which you're actually having to interfere a little bit more. Those diggers, they ain't natural. They ain't natural. So, is soft engineering? Here's a really key question. Listen really carefully to this. Is beach nourishment as soft an approach as managed retreat? Is it working with natural processes to the same degree? I put it to you that it's not. Oh no, listen, it's definitely not hard engineering. Definitely not. Oh no, 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 no. Don't you dare put it over there. Don't you dare put it over there. No, no, no. But I definitely don't want to put it all the way over here with this one. I kind of just nudge it a wee bit further there. Because here's the key. The processes that caused that beach to erode are still going on. And therefore, the beach will still be eroding away. And therefore, in time, you're going to have to come back and replenish the beach all over again. So whenever you're thinking about sustainability here, folks, yes, there is, I suppose, especially for GCSE, a simple, it's either or, it's one or the other category. But actually, it's probably better to be thinking on this continuum, this gradual change from one to the other. You've got things that are most definitely hard engineering and things that are most definitely soft engineering. Things that you would say would be soft engineering, yes, but not quite as far over. And I'm going to suggest to you that beach nourishment, although it is soft engineering, don't you tell me it's hard engineering. Don't. It is soft engineering. It's not quite as working with natural processes as managed retreat would be. So that's the first of our threshold concepts. Whenever you are talking about these things, whenever you're trying to make a decision based on this, that's what you really need to grasp in terms of sustainability. You're trying as much as possible working with those natural processes. Okay, and the second of the threshold concepts was this notion of the interconnectedness of physical systems. Now, this is something that we've met before in rivers. I did tell you there's a lot of overlap between rivers and coasts. We have met this before. In fact, you've seen this GIF before, knocking down all of the dominoes. If you do this here, that will have an inevitable knock-on effect all the way over there. The system is interconnected. Now, that's a really important point for you to pick up on whenever you're looking at any kind of management of any kind of coastal or indeed river, indeed any natural system. Let's have a look at something you've done before to remind you of this. Okay, so we're back into this Google Earth tour that Miss White did with you, and we're visiting here Shanghai, right? So Shanghai, this massive big port, population 27 million people, a really important area to protect. That was the arguments for coastal protection. But whenever we were looking at Shanghai, we didn't just look at Shanghai in itself. We came to take a look at, let's go further inland here, something that was happening a long, long way away, maybe 1,000 miles away inland, something like that, of the Three Gorges Dam. Now, why did we come all the way inland whenever we're looking at the port? Do you remember? There's the building of the dam in the Yangtze River. There's the river coming down to Shanghai. Why does building the dam here affect Shanghai? Do you remember? What is it that's trapped behind the dam? Beginning with S? Sediment. Less sediment comes down here. That, I don't know, look at that scale, 800 miles, 1,000 miles, something close to that. That massive journey. Less sediment comes down the river, less sediment arrives at the mouth. And again, think of what's one of the inputs of sediment into the coastal system. When you got from the cliff. Do you remember when I did the live stream at the beach? Do you remember the water was a browny colour? Remember the swoosh was a little bit of a browny colour? Do you remember all of that? That was the river bringing sediment that came onto the beach. And if you reduce the amount of sediment, you come on your head of me, aren't you? Input, output, stores, transfers. Input, output, stores, transfers. Sediment from the river is an input. You reduce the input, you have less sediment, and sediment is a natural defence against coastal flooding and erosion. But you've just reduced it. So there is that notion, folks, of that interconnectedness of the coastal system. Now, that's not the only place that we saw it. We saw it also here in our case study of coastal management of Cromer and Haysborough. Here we see Haysborough, a small village. Small village. You got that? Small village. And they have allowed the erosion to continue to take place here where these grounds have fallen into disrepair. They didn't maintain them because they are getting damaged, and because they're hard engineering, they have to be maintained over the long term. But the authority said, no, we ain't doing that no more. And we're all about soft engineering these days. We're not going to be protecting those grounds and replacing them and maintaining them and fixing them anymore. No. And look what happened. Getting the erosion taking place here. And we said to you it was like this took a bite out of the coastline. If you're getting erosion, input, output, store, transfer, input, output, store, transfer, which one is it? It's the input, isn't it? Input into the beach system. Now, why would you want an input into the beach system? Because further down the coastline here, you have got an important ecological and environmental area. That pink thing is an SSSI, Site of Special Scientific Interest. These protected. The law says in these protected. There are environmental laws that say you need to protect these sensitive habitats and environments. You have to. Now, how are you going to protect them? Where are you going to get sand to replenish these dunes? You got it, don't you? That sand comes from further up the coast there at Haysborough. Now, that is soft engineering. That's managed retreat, and it is soft engineering because we're working with natural processes. But why is it you can do that at Haysborough? Right, we're back to the arguments for coastal protection. Why is it? Because the small village, not a town, it's a small village. And that brings us then, folks, to this whole notion again of the interconnectedness of physical systems. That management strategies used in one place will have inevitable knock-on consequences elsewhere. Which brings us finally to your homework. Your job here was to find a more sustainable soft engineering solution. You wanted not to be using so many hard engineering strategies here at the town with the grounds. But you correctly identified, most of you, the fact that the sediment transport here is interrupted by the grounds means that less sediment is reaching here, which means that the salt marsh will be getting eroded. You correctly identified that. But what a lot of you then said was that what you wanted to do at this location of the salt marsh was, well, we need an input of sediment. If it's going to be eroded, we need an input of sediment. And how are you going to get sediment onto the beach? How are you going to do it? Well, what did most of you say? Most of you said this: beach nourishment. Let's add sediment to the beach. Well, is that an input? Sure. Is it sustainable? Are you going to have to come back in the future and do it again? You're going to have to come back again in the future and do it again. Is it sustainable? Well, yes, it is soft engineering. It's certainly more sustainable than seawall. Yes, it is definitely soft engineering. Yes. But is it the softest of engineering approaches? Or could we take a different approach? I wonder, are you already beginning to see how you might do that? Because there's another way that you could get an input of sediment, isn't there? You could get an input of sediment by allowing the grounds to break or remove them entirely and get the sediment being transported down from this part, from where the town is. Could you? Well, you could. That's another way of getting sediment down here to the salt marsh. Absolutely. That gets it down here to the salt marsh. But you see the problem, don't you? Because if you remove the grounds there, you reduce the beach there, and then what happens? You erode the town. Now again, the arguments for coastal protection, one of them is people live close to coastal areas and they need protected. Of course they do. I mean, look at the people, look at the economic costs of having that town eroded, look at the social costs of people being displaced. This is kind of like Cromer, isn't it? And they do still have the seawall there at Cromer. So where are you going to get sediment from? If beach nourishment is not the most sustainable approach, if you want to get rid of groins because they're not particularly sustainable, is there somewhere else we could get sediment from? I wonder. Yep, there absolutely is. The village. The wee small village. What's protecting? Well, if you live in that village, you think so. But look at that overview. The village versus the town. The economic costs of allowing the town to erode versus the village to erode. The village is like iceberg, isn't it? And what was the approach here? Managed retreat. Let erosion take place here. If you let erosion take place here, you have an input of sediment into the beach. Where did we see something like that? We saw it just here, did we not? Let me make this nice and big again so we can see it. Look at the input of sediment into the beach. And if we have that input of sediment to the beach, then we have a transfer of sediment from here to the town. You get the build-up of beach in front of the town, but because the grounds are gone, you allow that sediment to travel further on down here to the salt marsh. Now, I would argue that that is more sustainable because you're actually taking away one of the hard engineering strategies. You're using the most soft engineering strategy of managed retreat. Why? Because the economic justifications stack up. Tiny little village, not the town, tiny little village. That allows an input, that allows transfer or transport along here by longshore drift to protect the town, and allows transport by longshore drift to protect the salt marsh. What happens here has knock-on effects here and knock-on effects here. The interconnectedness of environmental systems. So sustainable is all about this carrying on into the long term with the minimum amount of additional input into the future. And when you're making those decisions, you need to make them based on this interconnectedness of the physical systems. Now, as you go on to take a look at Pacifica now, as you come up with your management strategies, this is what we're looking for. In a sense, there's no one single right or wrong answer. There are no simple, this is a perfect solution when it comes to managing natural environments. They're not. This is about weighing up the pros and cons. This is looking at the positives, the negatives, the good things and the bad things, and it's trying to maximize the positives and minimize the negatives. So what you're assessed on in something like this is not actually literally the decision you make, as much as it is the argument that you present to justify your decision. And not all arguments are created equally. Some arguments are much easier to knock down than others. The best decisions, therefore, are the decisions that are best supported by the evidence and the argument. So you're going to have to think a lot about this. Yeah, you get to make the decision, but you also have to justify that decision. So I'll be very, very interested to see what arguments you come up with. Have fun.